Dear learners, today I am going to discuss about packaging material for parenteral preparations. So packaging material for parenteral have the containers, closures as well as the tamper resistant material. But today we will see for containers as a packaging material for parenteral preparations. Now first of all, what is packaging? So packaging is the art and science which involves preparing the articles for transport, storage, display and use. The ideal container or package should be protect the contents from, means how the packaging should be. So whatever packaging is there, it should protect the contents from the light, temperature, moisture, atmospheric gases, particles, or we can say microorganisms. Now we will see the selection of packaging material, means which kind of care should be taken when we are selecting the packaging material. What are the criteria? So first is it must not be reactive with the product. Obviously, whatever packaging material we are selecting, it should not react with the product. It must not impart taste or we can say odors to the product. It must be non-toxic. Must be FDA approved. Whatever material we are selecting, it should be approved by Food and Drug Administration. It must meet applicable tamper resistant requirements. We will see this in detail. Adaptable to commonly employed high speed equipment. It should be adaptable to the equipment. Otherwise the packaging will not be done in the proper way. They must have reasonable cost in relation to the cost of the product. As per the cost, it should be compatible, means it should be reasonable in cost. Now we will see the type of pharmaceutical packaging. So there are three types of packaging. First is primary packaging, then secondary packaging and tertiary packaging. So what is primary packaging? Means this is the first packaging envelope or we can say the material which is in a directly touch with the dosage form or we can say the equipment. For example, we can say the bottles, cap, then cap liners. The packaging needs to be such that there is no interaction with drug and will provide the proper containment of pharmaceutical. For example, we can say the Bristol packages or strip packages. Means the primary packaging is the directly touch with the dosage form. Then what is secondary? Now what is secondary packaging? So secondary packaging means the package which stores the pharmaceutical packages in it for their grouping. For example, we can say the cartoons, the boxes are the secondary packaging material. Means which should be indirectly in a contact with the primary packaging. Now what is tertiary packaging? It should be in a contact with the secondary packaging. So what is tertiary packaging? This is to provide the bulk handling and shipping of pharmaceutical from one place to another. Means what? For example, here we can say the containers or we can say the barrels. These are the tertiary packaging. Now we will see what is container. So a container for a pharmacopoeial article is intended to contain a drug substance or drug product with which it is or may be in direct contact, and the closure is a part of container. When we are talking about what is the difference between container and closure, so closure is obviously the part of container and container which have the drugs. Now we will see the types of container. So there are generally 6 types of container. Here it is very clear by the pictures. First, the well closed containers. Now what is well closed container? For example, here we can see that it protects the contents from the loss during transportation. This kind of container, well closed container. or we can say when there is a storage or cell, it protects the drug. Then single dose container. Now what is single dose? For example, here we can see the ampoules and vials are a single dose container. Means containers which are used to supply only one of the medicament and hold generally the parenteral products. So these are the single dose container. Now the next is multi-dose container. So here we can see what is multi-dose. For example, we can say the vials. So multi-dose containers allows the withdrawal of dose at various intervals without changing the strength, we can say quality or purity of the remaining portion. And these containers hold more than one dose. These are multi-dose container. And this is a single dose container. Now next is a light resistant container. So here we can see the amber color bottles. So light resistant containers, they protect the medicament from the harmful effects of light. These are used to store the medicament which are the photosensitive. Now the next is airtight containers. So what is airtight container? Here we can see this kind of containers. These are the containers which have a airtight sealing, or we can say closing. These containers protect the product from the dust, moisture, and we can say air. That's why it is a airtight container. Then aerosol container. From this picture it is very clear what is aerosol container. So it is used to hold the aerosol products. And these containers have the mechanical strength, we can say, to bear the pressure of aerosol packaging. That's why this is a specific type of container for aerosol. Now we will see which kind of packaging material we are going to use. So there are two type of material. First is glass and second one is plastics. Now we will see the glass container in detail. So what is the composition of glass? It contains the sand, we can say silicon dioxide, sodium carbonate, calcium carbonate, broken glass. For example, it contained aluminium, boron, potassium, magnesium, zinc as well as the barium. Now it have this kind of colors. It's available in this kind of colors. First is amber color, which contain the light yellowish to deep reddish brown color of glass, carbon and sulfur, or we can say iron and manganese dioxide. Then yellow color glass contain the compounds of cadmium and sulfur. Blue color having various shades of blue, cobalt oxide, or we can say copper oxide, or we can say cupric oxides of blue color. Then green color means iron oxide, manganese dioxide and chromium dioxide. So this is the composition of glass, how the different colors are made up of, or we can say different color of glass is made up of. Now we will see the type of glass. So there are three type of glass mainly, and fourth one is a non-parenteral. So there are three type of glass generally: type 1, type 2 and type 3. So we will see the composition, advantages and uses of the particular type of glass. So first is type 1 glass. So type 1 glass is also known as neutral glass. It's made up of borosilicate glass. We can say silicon dioxide and boron oxide. That's why it is made up of borosilicate glass. What are the advantages of type 1 glass? First we will see what is the use of type 1 glass. So type 1 glass is suitable for packaging of all pharmaceutical preparation. It is widely used as a glass ampoules and vials to package fluids for injection, and is used to package solutions that could dissolve the basic oxides in the glass. We can say type 1 glass is generally made up of borosilicate. So these are the uses of type 1 glass. And what is the advantage? So it possesses a high hydrolytic resistance, and it is the most inert type of pharmaceutical glass. it has the lowest coefficient of thermal expansion. These are the advantage. Means what? What is the meaning of this sentence? We can say it is suitable for sterilization by heat for ampoules as well as vials. So these are the basic composition, advantages and uses for type 1 glass. Now we will see type 2 glass. So type 2 glass is also known as soda lime silica glass. So it is made up of soda. It is used to decrease the glass transition temperature of the silica. Here Na2CO3, it's made up of sodium carbonate, and here sodium carbonate is used to decrease the glass transition temperature of silica. Now what are the uses of type 2 glass? So it is used to package the aqueous preparation. It have a specific use for aqueous preparation, and as it contains the basic oxide, here we can see it have a sodium carbonate. So it is not used to package parenteral formulations with a pH less than 7. For example, it is a acidic, means we cannot pack the acidic material in type 2 glass. This would increase the pH. What happens if we will do that? This would increase the pH of the formulation and it could affect the drug stability and potency. As I have discussed, there are some criteria to select the type of material. So for basic material only we can select the type 2 glass. Now what are the advantages of this kind of material? So this glass has a lower melting point than type 1 glass, and it is easier to produce and consequently cheaper. It is cheaper and high hydrolytic resistant due to surface treatment of the glass. Here there is a surface treatment. For preparation there will be a surface treatment. That's why it have a high hydrolytic resistance. Now we will see type 3 glass. So type 3 glass, we can say the regular soda lime glass. It's a type 3 glass. It's a containers that are untreated. See, what is the difference between type 2 glass and type 3 glass? In type 2 we have the soda lime silica glass. But in type 3, it's a regular soda lime glass. It contains the untreated material, means are made up of commercial soda lime glass of average and are better than average chemical resistance. Now what are the uses? So for all solid dosage form it is used, and for oily injections. See, type 2 is for aqueous preparation, but here this glass is used for oily injections. What are the advantages? It contains high concentration of alkaline oxides and impart alkalinity to the aqueous substance. We can say flax separate easily from this kind of glass. We can separate the flax easily. Now we will see the next class is a NP, or we can say non-parenteral, the general purpose glass. So what is the composition? See, this is non-parenteral, means it is a general purpose soda lime glass. Not for specific, means we can say not specific for parenteral preparation. So what is the composition? So here the containers are made up of soda lime glass. It's supplied for non-parenteral products. Now what are the uses? For oral or we can say topical purpose. It's not for parenteral use. And what are the advantages? So it's intended for oral or topical uses. So basically for parenteral there are mainly 3 types of glass: type 1, type 2 and type 3. It's very important. Now we will see the plastics. The plastic material for packaging. So what is plastic? It is a wide range of solid composite material which are largely organic, usually based upon the synthetic resins, or we can say upon modified polymers of a natural origin and possessing the appreciable mechanical strength At a suitable stage in their manufacturing, most plastic can be cast, we can say, molded or polymerized directly into the shape. Now we will see the plastic containers in detail. There are two classes of plastic material. First is thermoplastic and second is the thermosets. So what is thermoplastic material? Means we can say it is capable of being shaped after initial heating and we can solidifying by cooling, and it is resistant to breakage and cheap to produce. For example, polystyrene, polyethylene and polyvinyl chloride. Now what is thermosets? So thermoset need heat for processing into a permanent shape. Means during heating, this kind of material form the permanent cross links between the linear chains. We can say it resulting in the solidification and loss of the plastic flow. These are thermosets. For example, phenolic, urea and melamine are the class of, or we can say example of thermoset class of plastic material. Now we will see the types of plastic. So there are many type of plastic material. We can say the polyethylene, polypropylene, polystyrene, polyvinyl chloride or polyvinyl chloride. Now first is polyethylene. So what is polyethylene and when it is used? So this is used as a high and low density polyethylene. And what are the properties of polyethylene? So it provides the stiffness, strength, or we can say toughness, its resistance to chemicals, and widely used for bottles for solid dosage form. Then polypropylene. So it is good resistant to heat sterilization. It is colorless, odorless, thermoplastic material with the excellent tensile properties even at a high temperature. So it is very important. Then polystyrene. So which kind of property it have? The versatility, in solution, clarity and easily formed. We can say styrofoam. It's a styrene, that's why styrofoam. And it is used for jars for ointment and creams with the low water content. This kind of material is used to pack the jars of ointment and creams with the low water content. Now the next is polyvinyl chloride. So it also have the versatility, the ease of blending, it have a strength, it provide the strength, resistant to grease or we can say oil, it provide the resistance to chemicals, clarity, it is used as a rigid packaging material and main component of intravenous bags. It is used to pack for intravenous, we can say as a bag. Then polyvinylidene chloride. So it is excellent barrier properties against the moisture, water vapor, then UV light, aroma, inorganic acids, alkalis, the salt solutions, organic water soluble acids, aliphatic hydrocarbons, the esters of a long chain fatty acids, the detergent based materials, emulsifying agent and wetting agents. So these are the type of plastic materials. Now we will see the drug plastic consideration. So when there is a drug plastic consideration, which kind of problems we will observe? So first is the permeation. Now what is permeation? So it is the transmission of gases, we can say vapor or liquid through the plastic packaging material, and permeation of water vapor and we can say oxygen through plastic wall into the drug is a major problem with the dosage form when it is sensitive to hydrolysis and we can say oxidation. So it is a permeation. Then leaching. So some plastic containers have one or more ingredients added to stabilize it. So this may leach into the drug product. So problems may arise with plastic when coloring agents are added in a small quantities to the formula. So this kind of problem we can avoid by avoiding the coloring materials. Then next is the sorption. So what is it? So this process involves the removal of constituent from the drug product by packaging material. The therapeutic efficacy of a product may be reduced due to sorption, and it may change the chemical structure, we can say pH, solvent system and concentration of the active ingredients. The next is a chemical reaction. We can say certain ingredients in a plastic formulation may react chemically with one or more components of a drug product. Then alteration, or we can say the modification. So the plastic materials, for example, the physical and chemical alteration of a packaging material by the drug product is called modification. Some solvent system found to be considerable changes in a mechanical properties of the plastic. For example, we can say the oils have a softening effect on a polyethylene hydrocarbon, or we can say the polyvinyl chloride. So we have to choose the plastic material by taking some care as per the properties of our drug substance. It is very important to avoid the drug plastic interaction. Now this is all about containers. Now in the next lecture we will see the closures as a packaging material. Thank you, dear learners.